Welcome to Sci-Fact Fusion. Today we gonna talk about
Later.
time.
We basically move through our days completely trusting the rhythm of our watches, fundamentally believing that a second passing for me is the exact same second passing for you. But today, we're looking at the Hefele-Keating experiment, a real moment in history that proved this comforting assumption is, well, absolutely wrong. We're going to explore a concept that honestly sounds like pure science fiction, yet it's absolute, measurable science fact. So, what if time isn't actually the same everywhere? We're just so conditioned to think of time as this universal background clock, right? Just ticking away at a constant, unyielding pace, no matter where we are or what we're doing. But what if your basic assumption of a ticking clock is just flawed from the start? What if the universe literally doesn't share a single synchronized heartbeat? Time. It's the one resource we can never, ever get back. Yet, from a physics standpoint, it's kind of the one thing we perhaps understand the least. All right, Section 1, the 1971 airplane experiment. Okay, let's dive into this. To test this deeply strange idea, scientists Joseph Hafele and Richard Keating hatched an incredibly ambitious plan. Step 1, take extremely precise cesium beam atomic clocks, clocks capable of measuring the tiniest fractions of a second. Step 2, fly them around the Earth on commercial airliners. But crucially, they did this twice, one trip heading east and another heading west. And finally, step 3, compare those airborne clocks to a stationary clock remaining perfectly still at the U.S. Naval Observatory. It was a massive, planetary-scale science project. Section 2, Einstein's theory of speed. So it all comes down to Einstein's theory of relativity, which is the scientific principle that time changes depending on an object's speed. According to Albert Einstein, the flow of time is not a constant, it's relative. If you're standing completely still, and I'm moving past you, my clock is fundamentally ticking at a different rate than yours. Actually, let me put it this way. A stationary object and a moving object literally experience the passage of time differently. But here's the catch, right? The difference should be so incredibly small, human intuition screams that absolutely nothing would happen at the speeds commercial airplanes fly. We don't feel time warping when we catch a flight. We entirely expect that after a trip around the world, the clocks will return completely unchanged. Which brings us to Section 3, the mismatched clocks. Now, what's really interesting about this slide is that the planes finally landed. The journey was over. We have the stationary clock that remained completely still on the ground, right side by side with the moving clocks that just flew all the way around the Earth. And when the scientists finally placed them together and checked the readouts, there was no way. They did not match. The ticking of the universe had actually split into different realities. Now, we're talking about fractions of a microsecond here. Specifically, compared to the ground clock, the eastward journey lost 59 nanoseconds, while the westward journey actually gained 273 nanoseconds. It's a tiny, tiny fraction of a second. But the sheer size of the number isn't what matters. It's the fact that it exists at all. Those tiny differences matched Einstein's theory perfectly. The clocks experienced different flows of time relative to the Earth. Time actually shifted. Section 4, traveling into the future. The absolutely crucial point is this: when something moves faster, time slows down for it. It really is that simple, and it's that astonishing. Speed directly affects the passage of time. The faster you hurl yourself through space, the slower you move through time relative to the people you left behind. Think about what this means for your own life. Like the quote says, every time you travel fast, you're moving just a little into the future. Every time you get on a highway, every time you board an airplane, you are aging slightly slower than the people standing still on the ground. When you land and step off that plane, you are, technically speaking, stepping into the future of the people you left behind. It's just by a microscopic fraction of a second, sure, but it is incredibly real. So time isn't what you think. It isn't this rigid track that we're all forced to walk down at the exact same pace. It's flexible, it's personal, and it bends to our movement. If a simple airplane flight can physically split the reality of a ticking clock, what else about our universe is hiding right under our noses, just waiting to be measured? Keep that thought with you the next time you look at your watch.